Manmat Kulkarni. I am the CTO of FinDNA Tech Corp, a fintech startup which had its beginnings in the third quarter of 2021. We develop enterprise core banking components for a living. I have been doing enterprise core banking software for the last 35 years. We have, as a customer of FinDNA, one of the largest private sector banks in India. Late 2020, early 2021, when I was evaluating different relational databases to underpin the FinDNA enterprise components, I evaluated quite a few of them and finally settled on YugabyteDB. One of the key features that I was grappling with and my team were grappling with over the last couple of decades was how do we set up our software in an active-active fashion so that two independent instances of our core banking software are able to handle transactions concurrently. Now for this, you needed all the underpinning components to work as active-active. Specifically, the relational store, data store, which should support bidirectional replication while both the instances are active. Now, the first thing that I chanced upon while looking at YugabyteDB documentation was the fact that they had support for bidirectional replication. And when I spoke to the co-founders and the product folks, I was delighted to know that it was a feature that they wanted to actively support in their design and had included it. So that's one of the key reasons why YugabyteDB will be critical for us, because in our existing site, we would deploy all our components across two different clouds in an active-active fashion. In production right now, we have one of our payment components in an active-passive on a single cloud provider, and in the next calendar year, we would be migrating that active-passive to an active-active. Another factor that attracted me to YugabyteDB was the ability to upgrade dynamically. That was another key constraint, that evaluation criteria that we had while looking at databases. We have upgraded YugabyteDB on our payments component in production at our customer site dynamically while transactions were on. The fact that the world is and will need an uptime of 24 hours entails that any one of the application components or the underpinning components have to be upgraded dynamically. Finally, as hardware improves and the volumes increase, it is incumbent on the bank to upgrade its hardware fairly frequently, especially in the cloud, as the cloud providers deprecate the older generation. In the bank's old data center, the bank can extend the lifetime of a hardware component, but in the cloud it becomes difficult. Yugabyte allows us to run its nodes on two different hardware generations of the same CPU architecture or different CPU architectures. This allows us to introduce current generation hardware and remove the previous generation hardware node by node. This also ensures that the uptime is 24 hours, and because of the hardware upgrade, the bank need not seek downtime from its customers. All in all, it has been a very pleasant experience working with YugabyteDB for the last 4.5 years, and our customer is also significantly benefiting from all the factors that I mentioned and the fact that they would see increasing uptimes while deploying our software on YugabyteDB. Thank you.
Hello, everyone. I am Nikhil Khanapurkar. I'm Senior Vice President at HDFC Bank, heading the program engineering function. I am also leading the core banking modernization and cloud adoption journey at the bank. I'm very happy to talk to you about how we are reimagining one of our most critical systems, that is the real time payment system. Uh, to set the context, HDFC Bank is one of the largest private sector banks in India and among the top globally by market cap. We've always believed in marrying scale with innovation, and our motto, "We understand your world," drives us constantly to improve customer experience across segments, that is, retail, corporate, SME, and rural. And payments, especially the digital ones, sit at the center of this vision. Uh, the challenge, how we are adapting to our future needs. So, our payments infrastructure served us well for more than a decade now, but we are seeing and feeling various pressure points. Growth in transaction volumes is exponential, and customers are also expecting availability 24 by 7. Maintenance windows, deployment bottlenecks, unpredictable workloads, and also rising infrastructure costs are really holding us back. And more importantly, our engineering teams are just working and keeping busy to keep the lights on and not on innovating anymore. So we asked ourselves, what should our payments platform look like? And we wanted something that was always on, highly elastic, simple to operate, and also allows us to move very fast. Our business depends on digital transactions, and we needed a real modern database that supports that scale and also reliability while helping us move quicker. Some of the migration considerations and goals. A project like this with national payment system in the picture has very low margins of error. Our goals were very ambitious. Zero downtime, gra- um, guaranteed data consistency, multi-cloud support, regulatory compliance, and no compromise on performance. Above all, we wanted to reduce operational complexity and also empower our teams. Choosing the right database was one of the most critical decisions we had to make. After a very careful evaluation and rigorous certification process, we chose Yugabyte as the core database of our new application stack. And I will describe some of the critical conditions that were considered before taking this decision. One of the primary requirements and design principles that we had set ourselves for was multi-cloud availability. As this gives us good flexibility both in terms of deployment and also high levels of availability. Yugabyte's support of deployment across all the popular cloud providers, along with the capability of cross cloud replication, met this requirement. And we did those various deployment tests and satisfied that our requirements were met. Being in the banking industry, another very critical aspect was asset properties for a relational database. Eventual consistency obviously is a non-starter for us, and Yugabyte provided these features and was one of the top considerations for us to choose the database. Uh, Third consideration, I would say, in order of priority, was then the availability aspects. Yugabyte's distributed nature provided very high levels of availability. Within a region, it tolerated component failures, it tolerated availability zone failures, and we actually did extensive tests, all destructive chaos type of testing, to ensure that the customer experience and transactions were never impaired when all these failures happened. And these were done to our satisfaction. A fourth aspect of availability also is requirement of maintenance windows, or basically zero downtime. 24 by 7 availability was very critical for us from a customer experience perspective. And in the past, we have seen that database upgrades, patches, security security posture updates do require some maintenance windows in the database platforms. Yugabyte was one platform which did not require these maintenance windows, and we did test all these before we certified that it is not only on paper but also in practice. Uh, and one of the probably one of the last critical considerations was the elastic nature of the database. While we build modern systems, we have containerized workloads, we are able to scale on demand at the middle layer. The database traditionally always has been the choke point, right? We are not able to scale that as per our demands. Now with Yugabyte, we were able to change both the shape and the size of both the compute as well as the storage. Now we had that ability to adapt to seasonal requirements as well as easily plan for growing demands and needs as business projections came in. So these aspects as well was something that we thoroughly tested during live transactions and peak loads. This was not in low times or nighttime kind of windows, but during peak loads. So this was another important consideration. Uh, and one sweetener to all these aspects was its Postgre compatibility. Of course, it gave us I would say, a fallback in case something went wrong. That was like an insurance for us, which is also important. But it also helped developers and DBAs to hit the ground running, because Postgre was generally, from an experience and expertise perspective, largely available, and we were able to really adopt the database very fast. So, in a nutshell, I would say these were the critical conditions why we chose Yugabyte. The application in question, we are talking about our enterprise payment hub. We decided to build our own payment platform from the ground up using a very modern microservices based, cloud native, cloud agnostic architecture. The platform powers critical national payment networks. IMPS is already live, and NEFT RTGS are on the way. These are not just bad jobs. These are real time, high transaction, high volume, high stake transactions. We're talking about million transactions a day with no room for either latency or failure. How did we go about approaching the transformation? We followed a very methodical engineering first approach. We started with a deep audit and a planning exercise, tying the dots together, looking at all the functional and non functional requirements. We refactored the entire code and the schema. We learned from our past mistakes and the design flaws. We adopted asynchronous and non blocking paradigms. And importantly, we built for observability and resilience from day one. After the build was over, the most important thing, we tested it rigorously. Both stress test, chaos text testing, functional validations, all of it. We did easy failures, we did unplanned downtimes, and moved ahead towards the cutover. One unique thing about the migration was we did not do a big bang cutover. We ensured a parallel coexistence run with the existing system. We had to invest on what we called as an insulation layer, which allowed us to gradually ramp up the load to the new system. keeping the risk minimal to the bank. And the results have been really good. We have achieved a very large uptime. There have been no maintenance windows. In fact, just recently in production, we completed a major database, Yugabyte database version upgrade with absolutely zero downtime and no customer impact. Chaos engineering is working with flying colors. We did tests in production, simulated failures in production, and the results are very satisfactory. Our disaster recovery posture has improved and observability also has deepened. We can now see our system live in action not like never before. And this wasn't just a tech success, it has been now a business enabler. What are some of the key learnings from our journey? So every project like this teaches you few truths. Some of them I'm just mentioning now. So start small, but have a bold vision. Real time metrics are really your North Star, it's the compass to your direction and the approach. Your people are your biggest asset. We have to invest in them, empower them for us to get the right deliveries. And finally, always we have to plan for failures because it's not an if, but it's a question of when. So these learnings have helped us avoid the pitfalls and build trust across the different teams. Looking ahead, we have built now a very solid foundation and we are not stopping here. A faster feature delivery is next, and more critical systems like pricing, origination, and other payment rails are all being lined up for modernization. We will soon see them in the coming years. Thank you for your time, and thanks to Yugabyte team and the community. If you are on a similar journey or planning one, I'm happy to share more and also learn from each other. Thank you.